Hello, welcome to Module SSC 30, Alignment Angle Basics. When we discuss alignment angles, we're referring to the angles that a vehicle's tires make in relation to the road surface and each other. Angles made by the positioning of certain suspension components will also be discussed. Understanding vehicle alignment angles is critical to repairing modern steering and suspension issues. After completion of this module, you will be able to describe what an angle is. You will also be able to identify and describe camber, caster, and toe, including individual toe and thrust angle. When discussing the subject of alignment angles, we first need to look at what an angle is. An angle is formed when two lines extend out in different directions from the same point. When discussing angles, we're typically referring to the amount that one line would have to move to bring both lines together. Alignment angles can be displayed in several different ways. The first is degrees. When measuring angles in degrees, think of a protractor with 360 degrees making up a full circle. If we zoom in on the protractor and draw a line at 0, making it the baseline, then draw another line and move it away from 0. Each small mark on the protractor the line passes is 1 degree from the baseline. You can see the symbol for degrees on the screen. But when dealing with alignment angles, we most often work with angles much smaller than 1 degree. One way to display angles smaller than 1 degree is by using decimal degrees. You can see here that if we move halfway between 5 and 6 degrees, we get 5.5 degrees. If we zoom in even further, we can see the measurements in hundredths of a degree, meaning the degree is broken down into 100 equally sized measurements. Angles smaller than 1 degree can also be shown in minutes. Just like there are 60 minutes in 1 hour, there are 60 minutes in 1 degree, meaning the degree is broken down into 60 equally sized measurements. So the 5.5 degrees we saw earlier could also be shown as 5 degrees 30 minutes. You can see that minutes are displayed with an apostrophe as shown. Some angles, such as toe, may be listed as a measurement, not a degree. When a dimension is given as a measurement, it's the difference between two distances. We'll discuss this in greater detail later in the module. You have now seen a variety of ways that alignment angles will be displayed, including degrees, minutes, or as a measurement. Now that we've seen what makes up an alignment angle, let's take a look at the basic alignment angles that we'll be discussing in this module. Those angles are camber, caster, and toe. Camber is the side-to-side tilt of the tire compared to true vertical, as seen from the front of the vehicle. This angle is measured for both the front and rear tires. Camber is important because it has an effect on vehicle ride quality, handling, and tire wear. Camber is measured as the number of degrees that the tire varies from true vertical. If the top of the tire is leaning away from the vehicle, the camber is positive. If the top of the tire is leaning towards the vehicle, the camber is negative. If the tire is parallel to true vertical, it has 0 camber. Caster is the forward or rearward angle of the steering axis compared to true vertical as seen from the side. On vehicles with a double wishbone suspension, the steering axis is found by drawing a line through the upper and lower ball joints on the steering knuckle. On vehicles with a McPherson strut suspension, the steering axis is found by drawing a line between the center of the upper strut mount and the lower ball joint. Caster is important because it has an effect on vehicle steering effort, steering wheel returnability, and handling. It can also affect tire wear when turning, which will be discussed in a later module. Steering wheel returnability refers to the vehicle's ability to straighten out and the steering wheel return to center after the vehicle leaves a corner. caster is measured as the number of degrees that the steering axis varies from true vertical. If the top of the steering axis is in front of true vertical, the caster is negative. If it's behind true vertical, the caster is positive. If the steering axis is parallel with true vertical, it has zero caster. Because the rear wheels have no steering axis, caster is not calculated for the rear in our vehicles. Toe is the comparison of the distance measured between the front and rear of the tires on the same axle. Toe is calculated for both the front and rear axles. Toe is important because it has an effect on tire wear, handling, and steering wheel alignment. Toe is represented by a measurement in either millimeters or inches, calculated by taking the distance between the rear of the tires and subtracting the distance between the front of the tires. This measurement is called total toe. You can see from our example that because the tires are parallel to each other, this vehicle has zero total toe. If the front of the tires were closer together than the rear, the vehicle would have positive toe, also called toe in. If the rear of the tire were closer together than the front, the vehicle would have negative toe, also called toe out. Now that we've learned how total toe gives us the distance between the front and the rear of the tires on one axle, there's another toe angle we need to discuss: individual toe. Individual toe is the comparison of the distance measured between the front and rear of one tire to a reference line, called the thrust line, which will be discussed later in the module. You can see that since individual toe only measures one tire at a time, you can have one tire on an axle with a measurable amount of individual toe, while the other tire has zero. Like total toe, if the front of the tire points in, the toe is positive. And if the front of the tire points out, the toe is negative. The thrust line represents the average direction that the rear tires are pointing. You can see that if individual toe is zero on both sides, both rear tires are pointing straight ahead, which also points the thrust line straight ahead. When individual toe is equal for each rear tire, the thrust line will continue to point straight ahead. However, if individual toe differs from side to side, the thrust line will point to the average of those directions. In order to use the thrust line to calculate an alignment angle, we must measure it against a reference line. The line we use for that reference is the geometric center line. The geometric center line is a line drawn between the center points of both the front and rear wheels of the vehicle. By measuring the angle between the thrust line and the geometric center line, we come up with the thrust angle. Thrust angle is important because it has an effect on vehicle tracking and steering wheel alignment. Let's take a look at how the thrust angle is calculated. The thrust angle is found by taking the individual toe on the left side and subtracting the individual toe on the right, then dividing that number by 2. You can see here that if the left rear tire has 2 degrees of individual toe and the right rear tire has 0 degrees of individual toe, the thrust angle will be 1 degree. If the thrust line points to the right of the geometric center line, the thrust angle will be positive. If it points to the left of the geometric center line, the thrust angle will be negative.